So we've got a scenario here with a pulley system. We've got two blocks, A and B, and block A is 400 grams, slightly heavier than block B, which is 300 grams. And they are both 1 metre off the ground. Now, what happens is block A is going to travel downwards for a certain amount of time until it hits the ground. But then we've got a scenario where the string snaps after half a second. So we want to look into what's been happening before and after that time. So we want the tension in the string, the acceleration of the system as it begins to move, and how far up does B travel. So basically the displacement of B from here as it travels up in half a second, the velocity of B at this time, and then after the string snaps, we've got these two questions we're going to look into. So first things first, we need to calculate the tension in the string and the acceleration of the system. So the acceleration of the system is going to be slightly different than the force of gravity. Now gravity would be pulling down on these weights, but the acceleration of the system will be counteracted by the weight of the blocks. So what we need as this system is moving, we need a system here called force equals mass times acceleration. Now they are Newton's equations of motion, and they're the rule we're going to follow to try and solve for all of these questions here. So calculate tension in the string and acceleration of the system. So what we need to do, we need to evaluate what's going on at A and at B. So if I do at A, and then we're going to work out the forces at A. So we've got tension. Now tension here in this string you can see is going upwards as it pulls against the direction of travel. So here tension is negative. And we've got the weight of the block, so we've got the mass of it, which is 400 grams, and the force of gravity. So that's going in the correct direction, so we will add 0.4 G. So we get that in terms of kilograms, as that's the SI unit. And then here at B, let's work out what's going on at B. I'm going to line these up in a nice little manner, so you'll see why that is in a moment. So at B, the system is travelling in this direction, so this time T is going in the right direction, so or the same direction as travel, so T is positive, and then the mass of the block pulling down with gravity, so that's going to be minus 0.3 G. And then what we do is we set each of these forces equal to mass times acceleration. So each of those will be the 0.4 A and 0.3 A. So the acceleration of the system is what we need to now find. So as we've got a system of two equations with two unknowns, G we do know, G is 9.81, we can now try and use simultaneous equations or substitution. I'm going to use simultaneous equations because I've got minus T and plus T, so if I add them, T's will disappear and I can just be left with this. So 0.4 G plus or minus 0.3 G, that's just simply going to be 0.1 G. And then if I add 0.4 plus 0.3, I get 0.7, and then 0.7A. And then just solve for A, just divide both sides by 0.7. So 0.1 G divided by 0.7. If I plug that into my calculator with G being 9.81, the acceleration of my system is going to come to approximately 1.4 meters per second squared. So acceleration, so that let's put that here, 1.4 meters per second squared. So that would be the answer to part 2. So that's good to go there. Now I need to calculate tension. As I've got acceleration, I can plug that into any one of these two equations and solve for T. So I've got a T here which is positive, that looks like easy to do. So if I just bring that one down here, I'll have T minus 0.3 G equals 0.3 times 1.4, as that's my acceleration. So now bring the 0.3 G across, so then T equals 0.3 times 1.4, that's going to be 0.42, and then add 0.3 times 9.81. And then if you plug that into your calculator, you should get approximately 3.36 newtons. So that would be the tension in the strings. If I'd have put it into that one, I would also get the same formula. I can leave that for you to check. So that's question 1 and question 2 taken care of. So I've got 3.36 newtons, 1.4 meters per second squared. Okay, so now I need to work out how far up does B travel. So what's the displacement of B after half a second, and what's the velocity of B at this time? So after half a second, what's its velocity? So we need to work out what that is. So now, as we've got equations of motion and we've got acceleration, the SUVAT equations will come in useful here. So if I just list out my variables and then see which ones we've got. So acceleration, we calculated, we know that's 1.4. And we're given the time in the question, which is half a second. So, or we could put 0.5 to keep it all in decimals, that's up to you. V, the velocity, that's what we want to find. U is the initial velocity. Well, it starts from stationary, so that's going to be a 0. And S is the displacement here, so that's also something we need to find. So which equations do we want to use first? So I've got a V, which I need to find. I've got a U given, an A given and a T given. So I can find velocity first if I wished. So I could use V equals U plus AT. So V equals U plus AT. So V is the variable we need, and then U is 0. And then add acceleration times time. So 1.4 times a half. So I'm just going to put 0.5 to keep it all in decimals, just easy to look at. So in which case velocity is going to be 0.7. And that's meters per second. So velocity at this time, 0.7 meters per second. Okay, now we need to find displacement. So for displacement, what I could use is the formula S equals UT plus a half AT squared. So I'm going to put that underneath here. So S equals UT plus 1/2 AT squared. Okay, now let's put all the variables in that I've got. U I've got, T I've got, A I've got, and T again I've got. So S is also what we need to find. So handily that's on the correct side of the equation, so I don't have to move things about. U is 0. So I've got 0 times a half. That's just going to give me 0. And then I've got a half. So I'm going to put 0.5 again, because my acceleration is also a decimal, times 1.4. And then T squared. What is T? T's 0.5. So I'm going to put 0.5 squared. Okay, right, let's work out what that is. Let's see if we can simplify this off a little bit. So 0.5 times 1.4 is 0.7. And then 0.5 squared is 0.25. Okay, so I need to find a quarter of 7, or a quarter of 7 is 1.75, but with the decimal 0.175. Okay, so that was in meters. So how far up does B travel in half a second? 0.175 meters. So keep it in the standard SI units. So that's that question there taken care of, and also that one there taken care of. So that's 3 and 4 all done as well. Now what happens is the string snaps, and I need to know how long it will take for B to hit the ground and at what velocity. So we need to do a new setup and find the new acceleration of the system. So where is B going to be now? Well, we already worked out it's gone up by 0.175 of a metre. So now if I just draw along the side here, that was our 1 metre. B's gone up by 0.175, so it's gone up by a little bit more. Obviously this is not going to be to scale, but we can see what's happening. And my block B now, as at this point. So if I'm going to set up some new SUVAT equations, my new distance is going to be 1.175. Is going to be the distance that it's going to travel. So how long will it take for it to the ground? That's what I'm going to need. So now I need to set up some new SUVAT equations. So let's write here what we have. So I'll just put these in a little box just to keep them separate. So S, U, V, A and T. Right, now what can I work out? Well, S is my displacement, so that's going to be 1.175. Okay, so now what's my initial velocity? Well, my initial velocity now in this scenario is going to be the speed that the block B was travelling as the string broke. Now it's going 0.7 meters per second, but it's going in the upwards direction. But we want to know stuff about what's going on in the downwards direction. So my initial velocity is now going to be a negative, so minus 0.7. Okay, now velocity is what we need to calculate. So what's the velocity as it hits the ground? So V is something we need. How long will it take? So T is another variable we need. And then acceleration, well, as the string breaks, the only acceleration acting on block B, because it's not attached to anything, it's just going to be the force of gravity, which is given as 9.81. Okay, so that's what we've got for our SUVAT equations. So now we need to work out what we can do, or which one would be better to be find first. So as we've got SUA and we need to find T, we could use the same equation that we used here, S equals UT plus 1/2 AT squared. Okay, now we need to find T, so we're going to end up with some sort of quadratic here. So S is 1.175, and then U times T, so that's minus 0.7T, plus 1/2 times acceleration, which is 9.81, and times that by T squared. Okay, so let's get this into quadratic form, bring everything onto one side and set it equal to 0, and then we can solve for T. And of course we'll get two solutions as it's quadratic. So half of 9.81, so that will become 4.905, and that's T squared. And then we've got minus 0.7T. And then if we bring this over to this side, that will also be negative. So minus 1.175, and that equals 0. So if you plug this into your calculator and solve this quadratic for T, you'll get two solutions. You'll get T is positive and a negative. You'll get negative 0.42 seconds approximately, or 0.566 seconds approximately. So if I just put a little equal sign there, as in approximately. Now here, T is negative. So we're looking what happens as it's falling. Well, some time is going to pass, so it's not going to be negative. So that one is no use to us. So that is what we're going to use as our answer. T is 0.566. So 0.566 seconds. That's how long it will take to hit the ground after the string snaps. And the last thing is we need to calculate the velocity. So for velocity, as we've got all the other variables, we might as well use this one again. So now V equals U plus AT. So V equals initial velocity, which is minus 0.7, plus 9.81 times T, which is now this number. And plug that also into your calculator, you'll get approximately 4.85. And that's meters per second. So that's going to be the solutions to our last two questions here. So 4.85 meters per second. And that completes all the parts to this question here. Okay.